This is going to be 10.2, the law of cosines. So in the previous video, we talked about the law of sines, and now we're going to talk about the law of cosines. So usually when we're doing the law of cosines is when you have side angle side, which is SAS, or side case. So you can see kind of like if you had two sides known, so let's say you need these two sides and then this angle, there's really no way that you can use the law of sines to try to figure that out. Same thing with the side. So if you have all three sides, there's no way that you would be able to figure out the angles themselves using the law of sines. And also, there's another case, angle. That's really not really a case because that's just, there's no way that you can figure that out. But using these two, we need another alternative method. So what we're going to do is we're going to try to derive the law of cosines. And this is basically the generalized Pythagorean theorem. So let me go ahead and just quickly derive the formula for you. So let me give this also angle B and also angle C. I think they got cut off. So here we have a triangle. Kind of very similar to the way that we were doing the law of sines. In this case, I have an extra little thing, which is going to be S. S is just basically this length. So the first thing that I'm going to start doing is I'm going to start off by looking at this triangle right here. And what we're going to do is we're going to take the cosine of this. So I'm going to take the cosine of A. And that's just going to be this angle S, this side S divided by B. Okay, that's what that is. So when I bring the B over, I'm going to have B cosine of A is equal to S. Okay, now right now, you might be wondering why am I doing this, and it'll all make sense. And now what I'm going to look for, I'm going to look for the sine of A. Okay, so when I look at the sine, it's going to be the opposite over the hypotenuse, so it's going to be H over B, move the B over. So B sine A is equal to H. So basically what I'm doing is that I don't really care about H and S. Really, I care about A, B, C, capitalized and lowercase. So I don't really care about S and H in particular. I just want to have some sort of expression that can kind of relate to S and H. That's basically all it is. So, and I'm keeping it handy there. So now what I'm going to look at, I'm going to look at the other side of the triangle, which is going to be this guy. So, and what I'm going to do is, you can see that by that Pythagorean theorem, we can try to figure out what all of these are. Now, if I know that this is S and this whole thing is C, then this little side right here is going to be C minus S. Okay, so using Pythagorean theorem, you can see that A squared is going to be equal to H squared plus C minus S squared using the Pythagorean theorem. Okay, so that's how I have that. And notice that I already have expressions for H. So I know that H is equal to the B sine of A squared, which is basically this guy. And then C, I don't know what that is. I'm going to leave it there. And then S is going to be equal to this guy right here, which is the B cosine A squared. Okay, and all I'm going to do is just use algebra and just FOIL things out. So this is going to be A squared is equal to B squared sine squared A, plus when I FOIL all this out, what I'm going to get is C squared minus 2CB. Oh, let me write BC instead. BC cosine A plus B squared cosine squared A. So if you really want to know what exactly I did there, I'm basically noting that there's a square there. I'm basically just foiling all of this out. Okay, so when you FOIL all that out, this is basically what you end up getting. So what I'm going to do now is that I'm going to combine these two guys together. So I'm going to have A squared is equal to B squared sine squared A, and then plus B squared cosine squared A. And then you have these guys left over, which is going to be this plus C squared minus 2BC cosine of A. So I'm going to factor out the B squared, and I'm going to be left with sine squared A plus cosine squared A plus C squared minus 2BC cosine of A. All right, so now notice here that I know that this is just an identity because sine squared plus cosine squared equals 1. So all I'm left with is just b squared because this thing is just going to be 1. Then plus c squared. So you can kind of see the Pythagorean theorem here, a squared, b squared, c squared. But then you have an extra thing. So minus 2bc cosine of a. Okay, this is what we call the law of cosines. Now, I could have immediately, if you look at back at the triangle, I could have solved for b instead, or use c, okay, and change the altitude. So if I do that, you're gonna get different variables in different places. So you're also gonna get b squared equals a squared plus c squared minus 2ac cosine of b, and you're also gonna get c squared equals a squared plus b squared minus 2ab cosine of c. So basically, there you have three different equations, which basically means the same thing depending on what size they give you. So this is basically what you would use for the law of cosines. Okay, so this is basically the law of cosines. So there's also other formulas where you are looking for the angle. You just move things around. I just basically just remember this formula, and that's basically it. So a little bit of the derivation, not that bad. I just wanted to show you where it comes from. Here is basically the law of cosines again. So if you're going to just take a look at it. And now what we're going to do is we're going to solve for a couple of do a couple problems using the law of cosines. Now, before we continue, I do want to tell you about these cases. So if you have the side angle side case, what I would suggest is solve for smallest angle first. Okay, just to prevent from giving the side angle, okay, or the angle side case, okay, because you don't want to do the two triangles again. So that's kind of, if you ever have a side angle side case, I would suggest to solve for the smallest angle first, because then you know that the angle itself, you can't have two triangles, because the smallest side is always going to have the smallest angle. So it can't be obtuse. If you have side, what I would suggest is solve for largest angle first, okay? And the reason why is because the largest angle is going to be basically the largest, the one with the largest side, okay? So if I haven't solved for any angles themselves, starting from the largest side will give you, it'll just be a little bit more safer. So this is basically what I would kind of recommend. So let's start off with a couple of problems. So here we want to find the unknown side and angles. So notice here we have the side angle side case, okay, and we have alpha, beta, and gamma. So in this case, what we want to do is we want to solve for the smallest angle. So the smallest angle is always going to have the smallest side, okay? So notice here, you have this 30 degrees, and you have this B, and then you also have this this A, and you have this C, this alpha and gamma. So let's try to solve for B, okay? So in this case, let's go, we're basically going to be using this formula right here. So I'm going to write it down, B squared equals A squared plus C squared minus 2AC cosine of B. Okay, in this case, it's going to be beta. So I'm going to have B squared is equal to A squared, which is 10 squared, plus 12 squared, which is C, minus 10 times 12 cosine of beta, which in this case is 30 degrees. Okay, so notice that angles cannot be negative, so even taking a square root to both sides, we don't need to put plus or minus because it's just going to be a positive side. So all we really have to do is plug in all of this. So I'm going to write the square root. So second square root, 10 squared plus 12 squared minus 2 times 10 times 12. And then we're going to write cosine of 30 degrees. Okay, and I ended up getting about 6. Okay, so that's going to be basically my answer for that one. So B equals 6. Okay, so this guy is just equal to 6. So now in this case, you have two different cases. So you can either solve for gamma or solve for alpha. So remember, when you have the side angle side case, what I said is always solve for the smallest one. So the smallest one or the smallest angle is going to be the one that has the smallest side. So if you can look opposite of it, you can kind of look at, okay, well, in this case, it'll be better to solve for alpha first, because I know that guy is going to be the smallest, because 10 is smaller than 12. So solving for alpha would be better. Now here you actually have a couple options. So you can use the law of cosines again, but you can see that it's going to be really computational. What I would suggest is just use the law of sines, okay? So just use the law of sines to be able to solve for the other angles. So I'm going to use sine alpha over A equals sine beta over B. So I'm looking for alpha divided by A, which is going to be 10. Then sine beta, so you're going to have sine of 30 degrees divided by B, which is going to be 6. Okay, so 6 sine alpha is equal to 10 sine 30 degrees. So I'm going to divide by 6. So I'm going to have sine alpha is equal to, whatever that is. So let me write 10 sine of 30 degrees divided by 60. And I'm going to get about 5/6. Okay, and then I'm going to take sine inverse. Okay, so this guy, sine inverse, is going to be 5/6. Okay, so this is going to give me about 56.4 degrees. And notice, because I solved for the smallest angle, you know that there's not a second triangle. Okay, there's no way that there can be a second triangle because you have an angle that's much larger than alpha. Okay, so that means that there's no way you can have another triangle, because if I did, then there's no way that I would be able to compensate for that angle, or maybe the angle beta. Okay, so this will be the answer for alpha. And now finally, we're just going to solve for gamma. And the way that we're going to do that is just by taking the 30 degrees. So gamma is going to be equal to just taking 180 and subtracting the angles that are given to us. So the first one was 30, so 30 degrees, and then plus 56.4 degrees. Okay, so this is going to give us 180 minus 30 plus 56.4. So then you're going to get 93.6 degrees. So kind of using the strategy of using the smallest angle actually is really good, because there's no way that this guy being the smallest angle and can be greater than 90 degrees, and that the sine inverse basically does that for you. So so it's a really good trick, and it kind of prevents you from using the law or the ambiguous case, the angle side case. Again, you could use the law of cosines again multiple times. If you are a law of cosines fan, you can just use the law of cosines to figure out the rest of them. Okay, now let's do one problem where it's side. So solve the following triangle given the following sides. So here, let me try to draw this. I'm just going to draw a generic triangle. Oh god. That's too big. Okay, so let's say we have a triangle that looks like that. So let's say A here is equal to 20, B is equal to 25, and C here is equal to 18. So here this figure is not drawn to scale. Okay, so here's where we want to be able to use the law of cosines. Because we have side. Notice that the law of sines would not be able to work because we need at least an angle there. So what we want to be able to do is let's go ahead and solve for an angle. Now the thing is, which angle should we solve for? Well, in this case, we should probably solve for the one that's larger, because we know that the one that's larger is going to give us maybe the biggest angle, and we know that the angles, the other angles are not going to be more than that particular angle because it's the largest. So we're going to go ahead and just use the largest one. So in this case, the largest one seems to be B. So B is the larger, so let's solve for this angle B. So I'm going to use B squared is equal to A squared plus B squared minus 2AB cosine, oh that's wrong, 2AC. 2AC cosine of oh God, of big B. All right, so now let's plug it in. So we're going to have 25 squared is equal to a squared, which is 20 squared, plus 18 squared, minus 220 times 18, cosine of b, whatever that may be. Now in this case, you can see that it's kind of complicated. We do need to solve for the value of cosine of b. So I'm going to move this 20 squared over first. So I'm going to have 25 squared minus 20 squared equals 18 squared minus 220 times 18, cosine of b. Then I'm going to move this 18 also. So I'm going to have 25 squared minus 20 squared minus 18 squared equals negative 220 times 18, cosine of b. And then finally, we're just going to divide this guy over since they're being multiplied. So I think this is a better strategy than trying to do it all at once. So you're going to have cosine of b is equal to 25 squared minus 20 squared minus 18 squared over negative 220 times 18. Okay. So now all we got to do is just take the cosine inverse to both sides. So I'm going to take the cosine inverse of this entire thing. So I'm going to write cosine inverse of 25 squared minus 20 squared minus 18 squared, and then divided by negative 2 times 20 times 18. Okay, and I'm going to get about 82 degrees. So that is what b is equal to, 82 degrees. All right, so now what we want to do is figure out the other angles. So now the other ones don't really matter. I would still say that let's just solve for C in this case, because we know that the other ones, there's no way you can get two triangles because you already solved for the largest one. So everything else is going to be less than 82 degrees. So let's just solve, I don't know, let's just solve for angle C. So I'm going to use the law of sines. I think that's easier. I don't want to use the law of cosines again because you can see that it's really hectic. So I'm going to use law of sines. So I'm going to have sine C over C equals sine B over B. So sine C over 18 equals sine, 82 over 25. So cross multiply, 25 sine C equals 18 sine of 82. So I'm going to divide by 25. Sine C is equal to whatever the heck that is. So let me go ahead and plug it in. So I'm going to have 18 sine of 82 divided by 25. That gives me 0.71. And then I'm going to just take inverse sine. So inverse sine of the answer. And I get about 45.5 degrees. And now that I have C, I can figure out what A is. So A is just going to be 180 minus the other one. So of course you can use law of sines or cosines, but I think this is just going to be easier. So 180 minus, what is this, 82 plus 45.5. And that's going to give me 52.5 degrees. Okay, and that's how you do these types of problems.